Question third. Find the point on the x-axis which is equidistant from a minus 3, 4 and b 1 minus 4.
Question third. Solution. Let
px0 is a point on x-axis equidistant from a minus 3, 4 and b 1 minus 4. Okay, as p is a point on x-axis, its y coordinate is 0, and as it is equidistant from points a and b, therefore by distance formula AP equals BP. Okay, what is the distance of P from A? That is the distance of P from B. Okay, and therefore according to distance formula, AP equals under root x2 minus x1 bracket square plus y2 minus y1 bracket square. For AP, A will work as x1 y1, P will work as x2 y2. Okay, and therefore x2 minus x1 means x minus minus 3, x minus minus 3 its square, plus y2 minus y1 square means 0 minus 4 square, 0 minus 4 square equals BP. For a distance BP, B will work as x1 y1 and P will work as x2 y2. Therefore x2 minus x1 means x minus 1, x minus 1 its square, plus y2 minus y1 square means 0 minus minus 4 bracket square. Okay, and therefore squaring both sides we get x minus minus will become plus 3 its square, plus 0 minus 4 bracket square gives us minus 4 its square equals x minus 1 its square plus 0 minus minus 4 bracket square means plus 4 its square. Okay, squaring both sides, we get an equation like this. And therefore now it is in a form of a plus b bracket square. Expansion of a plus b bracket square is a square plus 2ab plus b square. Using this identity, we may write it as x square plus 2 into x into 3 plus 3 square plus square of minus 4 is 16. That equals, at the right side, x minus 1 its square is in a form of a minus b bracket square. Expansion of a minus b bracket square is a square minus 2ab plus b square. Okay, applying this identity, we can write x square minus 2 into x into 1 plus 1 square plus square of 4 is 16. Plus 16 from left will cancel with plus 16 at right. Okay, and therefore again it will be x square plus 2 3s are 6x plus 3 3s are 9. That equals x square minus 2 into 1 gives us minus 2 into 1 gives us minus 2 into x gives us minus 2x plus 1. X square from left will cancel with x square at right, and therefore 6x minus 2x on transfer from right to left we get plus 2x. That equals 1 plus 9 will become minus 9 at right side, and therefore 8x equals minus 8, and therefore x equals minus 8 upon 8. 8 ones are 8, 8 minus ones are minus 8, and therefore x equals minus 1, and therefore P, whose coordinates are x0 and where value of x is minus 1, P minus 1 0 is a point on x-axis equidistant from A minus 3, 4 and B 1 minus 4. Okay. Question 4. Verify that points P minus 2, 2, Q 2, 2 and R 2, 7 are vertices of a right angled triangle. Question 4.
Solution. Let
P minus 2, 2 is x1, y1. Q 2, 2 is x2, y2 and R 2, 7 is x3, y3. Okay. Therefore, by distance formula, PQ equals under root x2 minus x1 bracket square plus y2 minus y1 bracket square is equals under root x2, value of x2 is 2 and value of x1 is minus 2. That's why it will be 2 minus minus 2 its square plus value of y2 is 2 and value of y1 is 2. That's why 2 minus 2 its square equals under root 2 minus 2 gives us 2 plus 2 its square plus 0 its square is equals under root 4 square. And under root 4 square means 4 and therefore PQ equal to 4. Let's call it as equation first. Okay. Similarly, QR equals under root x3 minus x2 bracket square plus y3 minus y2 bracket square is equals under root value of x3 is 2 and value of x2 is again 2. That's why it will be 2 minus 2 its square plus value of y3 is 7 and value of y2 is 2. That's why it will 7 minus 2 bracket square is equals under root 0 square plus 7 minus 2 gives us 5 its square. Okay, equals under root 5 square and under root 5 square means 5. Therefore, QR equal to 5. Equation second. PR equals under root x3 minus x1 bracket square plus y3 minus y1 bracket square is equals, okay, x3 is 2 and x1 is minus 2. That's why it will 2 minus minus 2 its square plus y3 is a 7 and y1 is 2. That's why it will 7 minus 2 its square is equals under root 2 plus 2 its square plus 5 its square is equals 2 plus 2 means 4 its square plus 5 square is 25, square of 4 is 16, root of 16 plus 25 equals root of 41. Therefore, PR equals root of 41. Equation third. Okay, we are interested to verify whether these are the vertices of a right angle triangle or not. Okay, and for that we need to apply converse of Pythagoras theorem. Means we have to check whether square of the longest side is equal sum of the squares of remaining smaller sides or not. Okay, here PQ square will be 4 square. Okay, means square of 4 is 16. QR square is equals 5 square equals 25 and PR square equals square of root 41 and square of root 41 is 41. 16 plus 25 gives us 41, means square of the longest side equals sum of the squares of remaining two sides, and therefore by converse of Pythagoras theorem we may declare these are the vertices of right angled triangle. Okay, and therefore from 1, 2 and 3, okay, 4 square plus 5 square equals root of 41 square, that is PQ square plus QR square equals PR square, and therefore by converse of Pythagoras theorem, triangle PQR is a right angled triangle at vertex Q, and therefore P minus 2, 2, comma Q 2, 2 and R 2, 7 are vertices of right angled triangle. Right angled triangle. Question 5th. Show that points P2 minus 2, Q7 3 are 11 minus 1 and S6 minus 6 are vertices of a parallelogram. Okay. Question 5th. Solution. We are interested to prove that given points are vertices of a parallelogram. And we know that a quadrilateral is a parallelogram if its opposite sides are parallel, or if the opposite sides of a quadrilateral are equal, then we can say it is a parallelogram. Okay. Here we are going to prove that opposite sides are equal by using distance formula. Okay. Here P is 2 minus 2, Q is 7, 3, R is 11 minus 1 and S is 6 minus 6. Let P is x1 y1, Q is x2 y2, R is x3 y3 and S is x4 y4. Okay. Let in quadrilateral PQRS P2 minus 2 is x1 y1, Q 7 3 is x2 y2, R 11 minus 1 is x3 y3 and S, which is 6 minus 6, 6 minus 6 is x4 y4. Okay, and therefore by distance formula, PQ equals under root x2 minus x1 bracket square plus y2 minus y1 bracket square. Okay, and we know that x2 minus x1 bracket square plus y2 minus y1 bracket square is x1 minus x2 bracket square plus y1 minus y2 bracket square. Okay, let's write it as is equals under root x1 minus x2 bracket square plus y1 minus y2 bracket square is equals under root. Value of x1 is 2 and value of x2 is 7. That's why it will 2 minus 7 its square plus y1 is minus 2 and y2 is 3. That's why it will minus 2 minus 3 its square is equals minus 5 its square plus minus 5 its square. It should be under root minus 5 square plus minus 5 square is equals under root 25 plus 25 is equals under root 50, and under root 50 means under root 25 into 2. Therefore, PQ equals 5 root 2, equation first. Similarly, QR equals under root x2 minus x3 bracket square plus y2 minus y3 bracket square. Okay, that equals under root x2 is 7 and x3 is 11, means 7 minus 11 its square plus y2 is 3 and y3 is minus 1. That's why it will 3 minus minus 1 its square is equals under root minus 4 square plus 4 square equals under root 16 plus 16 equals under root 32 equals under root 16 into 2. Therefore, QR equals 4 root 2, equation second. RS equals under root x3 minus x4 bracket square plus y3 minus y4 bracket square is equals under root x3 is 11, x4 is 6. That's why it will 11 minus 6 its square plus y3 minus y4 means minus 1 minus minus 6, minus 1 minus minus 6 its square is equals under root 5 square plus minus 1 minus minus 6 means minus 1 plus 6, minus 1 plus 6, that is 5 its square is equals under root 25 plus 25 equals root of 50. Okay, and root of 50 means root of 25 into 2, and therefore RS equals 5 root 2, equation third. Okay, now PS equals under root x1 minus x4 bracket square plus y1 minus y4 bracket square is equals under root x1 is 2 and x4 is 6. That's why it will 2 minus 6 its square plus y1 is minus 2 and y4 is minus 6. Minus 2 minus minus 6 its square is equals under root minus 4 square plus minus 2 minus minus 6 means minus 2 plus 6. Minus 2 plus 6 gives us 4. Its square will be there equals under root 16 plus 16 equals root of 32 equals root of 16 into 2. And therefore, PS equals 4 root 2. Equation 4. Okay. Equation 1 tells us PQ equals 5 root 2. Equation 2 tells us QR equals 4 root 2. Equation 3 tells us RS is equals 5 root 2. And equation 4 tells us PS equals 4 root 2. And therefore from 1, 2, 3 and 4, from 1, 2, 3 and 4, therefore from 1, 2, 3 and 4, PQ equals RS. PQ equals RS. And QR equals PS. QR equals PS. PQ equals RS and QR equals PS. And therefore, as opposite sides of quadrilateral PQRS are equal, and therefore quadrilateral PQRS is a parallelogram. Okay, quadrilateral PQRS is a parallelogram. Question 6. Show that points A minus 4 minus 7, B minus 1 2, C 8 5 and D 5 minus 4 are vertices of rhombus ABCD. Question 6. Solution. Okay. According to given information, we are interested to prove that given vertices are vertices of rhombus. Okay, A, B, C, D. Quadrilateral ABCD is a rhombus, and we know that if all the sides of quadrilateral are equal, then it is a rhombus. Means if we are able to prove that AB equal to BC equals CD equals AD, then we may declare quadrilateral ABCD is a rhombus. Here it tells us coordinates of A are minus 4 minus 7, coordinates of B are minus 1 2, coordinates of C are 8 5 and coordinates of D are 5 minus 4. Okay, let A minus 4 minus 7 is x1 y1, B minus 1 2 B x2 y2, C 8 5b x3 y3 and D 5 minus 4 is x4 y4. Let's mention these things in a solution. Okay, let in quadrilateral ABCD A minus 4 minus 7 is x1 y1, B minus 1 2 is x2 y2, C 8 5 is x3 y3 and D 5 minus 4 is x4 y4. Therefore, by distance formula, AB equals under root x1 minus x2 bracket square plus y1 minus y2 bracket square. is equals under root -4 minus 1 its square plus -7 minus 2 its square is equals under root -4 plus 1 its square plus -9 its square is equals under root -3 its square plus -9 its square. Square of -3 is 9 plus square of -9 is 81 is equals root of 90, and root of 90 equals root of 9 into 10. Therefore AB equals 3 root 10. Equation first. Similarly, BC equals under root x2 minus x3 bracket square plus y2 minus y3 bracket square is equals under root -1 minus 8 its square plus 2 minus 5 its square. 2 minus 5 its square is equals under root -9 square plus -3 square equals root of 81 plus 9 equals root of 90 equals root of 9 into 10, and therefore BC equals 3 root 10. Equation second. CD equals under root x3 minus x4 bracket square plus y3 minus y4 bracket square is equals under root 8 minus 5 bracket square plus 5 minus -4 bracket square is equals under root 3 square plus 9 square equals under root 9 plus 81 equals root of 90 equals root of 9 into 10. Therefore CD equals 3 root 10. Equation third. AD equals under root x1 minus x4 bracket square plus y1 minus y4 bracket square is equals under root x1 is -4 and x4 is 5. That's why it will -4 minus 5 its square plus y1 is -7 and y4 is -4. That's why it will -7 minus -4 its square is equals under root -9 square plus -7 minus -4 bracket square means -7 plus 4 bracket square. -7 plus 4 gives us -3. Okay, that's why it will -3 square is equals root of 81 plus 9 equals root of 90 equals root of 9 into 10. Therefore AD equals 3 root 10. Equation 4. And therefore from 1, 2, 3 and 4 AB equals CD, AB equals BC equals CD equals AD. That is all sides of quadrilateral ABCD are equal. Therefore, quadrilateral ABCD is a rhombus. Quadrilateral ABCD is a rhombus. Okay. Question 7. Find x if distance between points Lx7 and M115 is 10.
Question 7. Solution.
Let Lx7 is x1 y1, M115 is x2 y2, and therefore by distance formula Lm equals under root x1 minus x2 bracket square plus y1 minus y2 bracket square. That is Lm equals under root x minus 1 bracket square plus 7 minus 15 bracket square. Let's call it as equation first. But according to given information, Lm equals 10. Let's call it as equation second since it is given. And therefore, from 1 and 2, under root x minus 1 its square plus 7 minus 15 its square is equal to 10. And therefore, squaring both sides, by squaring both sides, we get x minus 1 its square plus 7 minus 15 is minus 8 its square equals 10 its square. And therefore, x minus 1 its square plus square of minus 8 is 64, that equals square of 10 is 100. Therefore, x minus 1 its square equals 100 minus 64. Therefore, x minus 1 its square equals 36. And therefore, x minus 1 equals plus or minus 6. And therefore, x equals 1 plus or minus 6. And therefore, x equals 1 plus 6 or x equals 1 minus 6. And therefore, x equals 7 or x equals minus 5. Question 8. Show that the points A12, B16, C1 plus 2 root 3, 4 are vertices of an equilateral triangle.
Question 8. Solution.
Okay. We are interested to prove that given vertices are vertices of equilateral triangle ABC. And equilateral triangle is a triangle whose all sides are equal. If we are able to prove that AB equal to BC equal to AC, then we may declare triangle ABC is equilateral triangle. Here A is 1, 2, B is 1, 6 and C is 1 plus 2 root 3, 4. Okay, let A is x1, y1, B is x2, y2 and C is x3, y3. Okay, let in a triangle ABC A12 is x1, y1, B16 is x2, y2 and C 1 plus 2 root 3, 4 is x3, y3. Okay. Therefore, by distance formula, AB equals under root x1 minus x2 bracket square plus y1 minus y2 bracket square is equals under root 1 minus 1 bracket square plus 2 minus 6 bracket square is equals under root 0 square plus minus 4 square is equals root of 16, and therefore AB equals 4. Equation first. Similarly, BC equals under root x2 minus x3 bracket square plus y2 minus y3 bracket square is equals under root value of x2 is 1 and value of x3 is 1 plus 2 root 3. That's why it will 1 minus in bracket 1 plus 2 root 3. Okay, it's square plus 6 minus 4 bracket square. 6 minus 4 bracket square. That equals under root. Okay, let's off bracket in a bracket. 1 minus 1 minus into plus gives us minus 2 root 3 square plus 6 minus 4 gives us, yes, it gives us 2 its square is equals 1 minus 1 will cancel each other, minus 2 root 3 bracket square will be 4 into 3. Okay, 4 into 3 plus square of 2 is 4 and then 4 3s are 12 plus 4 equals root of 16, and therefore BC equals once again 4. Equation second. AC equals under root x1 minus x3 bracket square plus y1 minus y3 bracket square is equals under root in a box bracket. x1 is 1, x3 is 1 plus 2 root 3, means it will be 1 minus in bracket 1 plus 2 root 3 bracket square plus y1 is 2 and y3 is 4, that's why it will 2 minus 4 bracket square is equals, once again let's off bracket in a bracket in a box, under root in a box bracket 1 minus 1 minus 2 root 3 bracket square plus 2 minus 4 bracket square means minus 2 its square, plus 1 minus 1 will cancel, is equals under root minus 2 root 3 bracket square means square of minus 2 is 4 and square of root 3 is 3, that's why 4 into 3 plus square of minus 2 is 4 is equals under root 12 plus 4 equals root of 16, and therefore AC equals 4, equation third, and therefore from 1, 2 and 3 in a triangle ABC, AB equals BC equals AC, and therefore triangle ABC is an equilateral triangle. Is equilateral triangle. Okay, AB equals BC equals AC. Therefore, triangle ABC is an equilateral triangle. Thank you.